When we think about stars, we often picture tiny shining points in the night sky, which is how we perceive them from Earth. However, one star, Betelgeuse, is quite different. This prominent star is significantly larger than our Sun and has baffled scientists for a long time. Recently, alarming developments regarding Betelgeuse have emerged, prompting concern among scientists and astronomers alike. In this video, we will explore the stunning revelations about Betelgeuse, its impending destruction as observed by the James Webb Space Telescope, and the potential implications for our world, as explained by physicist Michio Kaku. Betelgeuse is a massive star that has captivated astronomers for years. Discovered by the ancient Greek astronomer Aratus, Betelgeuse is so large that it can be seen in the night sky, especially during winter. If you enjoy stargazing, you've likely encountered or heard of this reddish-orange star, which marks the upper left shoulder of the constellation Orion. Despite its size and brightness, Betelgeuse is an aging star, and its behavior is anything but stable. One of its defining characteristics is its variability. It pulsates in brightness, a unique property among stars. Let's delve into some of Betelgeuse's specific characteristics. Most stars visible in the night sky are quite distant from Earth, with the nearest star being 4.2 light-years away. To put that into perspective, if you were to travel at the speed of light for an entire year, you would cover a distance of 186,000 miles per second. This means that the nearest star is billions of miles away from Earth. Betelgeuse, on the other hand, is located approximately 600 light-years away, which means that even traveling at light speed, it would take 600 years to reach it. Yet, despite this vast distance, Betelgeuse shines brightly in our sky. So, how can Betelgeuse be so luminous despite its distance? This is due to its immense size and luminosity. Betelgeuse is about 1,000 times larger than our Sun and is believed to have a radius approximately 1,000 times that of the Sun. Unfortunately, when viewed through advanced telescopes, it appears as a disk rather than a point of light. Most stars appear as tiny dots because of the physical processes occurring in their outer layers. In terms of mass, Betelgeuse weighs between 12 to 19 solar masses, where one solar mass is approximately 2 times 10 superscript 2 kilograms. Scientists struggle to determine its exact mass since there are no nearby celestial bodies to use as references, and direct measurement is impossible from Earth. Thus, we estimate that Betelgeuse is around 18 to 19 times more massive than our Sun. Its brightness varies between magnitudes +0 and +1.6, making it 16,000 times more luminous than the Sun. This is why it's often referred to as a red supergiant. The pulsating nature of Betelgeuse is attributed to its expanding and contracting cycles. When it expands, it becomes brighter, and when it contracts, it dims. This cycle can last anywhere from 10 to 100 days or even longer. Betelgeuse's surface is covered in dark magnetic spots, which have much stronger magnetic fields than the surrounding areas. These magnetic spots inhibit the flow of hot gases to the star's surface, causing those regions to be cooler. The fact that Betelgeuse has many of these spots compared to our Sun explains why it is cooler, despite its size and brightness. For comparison, the magnetic spots on Betelgeuse can be twice the size of Earth. Additionally, it has a magnetic field that is about 15 times stronger than that of the Sun. This strong magnetic field causes the gases on Betelgeuse's surface to appear in arcs or loops when viewed through a telescope. The star has a surface temperature of around 3,500 Kelvin, which contributes to its lower energy output and reddish hue. Interestingly, Betelgeuse wasn't always a red star. It was once yellowish around 100,000 years ago. Over time, it transitioned to orange and then to the red star we see today. This change in color has led astronomers to believe that Betelgeuse is in the later stages of its life cycle. It produces up to 100,000 times more energy than the Sun, which would make it a formidable competitor to our Sun if it were closer. Remarkably, Betelgeuse, located 600 light-years away, can still be seen with the naked eye at night. In contrast, our Sun is only 8.3 light-minutes from Earth, which is why it appears so bright. If Betelgeuse were any closer, it could outshine the Sun, potentially engulfing Earth and the nearby planets due to its massive size. Even if it were to match the Sun's brightness, it would still emit more radiation than our Sun. Known as Alpha Orionis, Betelgeuse is an enormous star situated in the constellation Orion, about 600 light-years from Earth. Its size is one of its most striking features. It is roughly 1,000 times larger than our Sun and could easily encompass Jupiter's orbit if placed at the center of our solar system. Despite its vastness, Betelgeuse is not the largest star known. Its mass is estimated to be between 12 and 19 solar masses. This variability in mass assessment arises from the challenges in accurately measuring the mass of stars that lack companion stars or other objects for gravitational reference. Nonetheless, even at its lower estimated mass, Betelgeuse remains a colossal celestial object. Its luminosity is another significant characteristic, fluctuating over time with brightness ranging from magnitude +0 to +1.6. To give you a frame of reference, a magnitude 0 star is approximately 2.5 times brighter than a magnitude +1 star. At its brightest, Betelgeuse can be up to 1,000 times more luminous than our Sun. This variability is attributed to its pulsations, intermittent expansions and contractions caused by internal processes. As Betelgeuse expands, it shines brighter, and as it contracts, it dims. These pulsations can last from days to months, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a massive star, around 3,500 Kelvin, giving it a distinctive reddish-orange tint typical of red supergiant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in a late stage of stellar evolution, having exhausted the hydrogen fuel in its core and begun fusing heavier elements. This fusion process generates energy and causes the star to expand. Betelgeuse's atmosphere is rich in complex physical phenomena, including large dark magnetic spots on its surface, significantly larger than those found on the Sun. These regions of intense magnetic activity restrict the flow of hot gases from the star's interior to its surface, resulting in cooler areas. Studying these magnetic features offers insights into stellar dynamics and their effects on the behavior of massive stars. An unmistakable celestial object recognized since ancient times, has been observed and documented by various civilizations throughout history. Its visibility in the night sky, particularly during winter in the northern hemisphere, has made it a prominent feature in star charts and mythologies. Recently, Betelgeuse has attracted heightened scientific interest due to its dimming events that began in late 2019 and continued into mid-2021. During these periods, the star's brightness dropped to remarkable levels, sparking speculation among astronomers regarding its potential fate. Known as a prominent star in the constellation Orion, Betelgeuse is located about 600 light-years from Earth. It stands out not only as one of the brightest stars in the night sky but also due to its enormous size and variability. This red supergiant star has fascinated astronomers and stargazers alike for centuries, offering insights into cosmic evolution across vast distances and the fundamental nature of the universe. Betelgeuse is classified as a red supergiant, indicating that it is in the later stages of its stellar evolution. In terms of size, it is estimated to be around 1,000 times larger than our Sun, which means it would extend far beyond the orbit of Mars if placed at the center of our solar system. Despite its massive size, Betelgeuse is not the most massive star, with its mass estimated to range from about 12 to 19 times that of the Sun, depending on various assessments and calculations. One of the most intriguing characteristics of Betelgeuse is its variability in brightness. Unlike our Sun, which maintains a generally stable luminosity over time, Betelgeuse undergoes unpredictable fluctuations in brightness. These changes are attributed to pulsations within the star, resulting from shifts in its internal processes. At its brightest, Betelgeuse can shine up to 1,000 times brighter than our Sun, but during dimming episodes, its brightness can significantly decrease. This variability has been a focus of extensive study among astronomers, providing crucial insights into the star's life cycle and physical properties. Understanding the mechanisms behind Betelgeuse's brightness fluctuations is essential for unraveling the complexities of stellar evolution and the behavior of massive stars. With a surface temperature of around 3,500 Kelvin, Betelgeuse is relatively cool for a star of its size, giving it a distinctive reddish or orange hue. Spectroscopic analysis of the star's spectrum reveals absorption lines that indicate the presence of various elements in its atmosphere, including hydrogen, helium, and heavier elements formed through nuclear fusion processes occurring deep within the star. Betelgeuse exhibits significant magnetic activity on its surface, characterized by dark magnetic spots. These spots are regions where the star's magnetic field is much stronger than in surrounding areas, hindering the convection processes that transport heat from the star's interior to its surface, resulting in cooler regions. Betelgeuse has been known and observed by human civilizations for millennia. Ancient astronomers from various cultures, including the Greeks, Egyptians, and Chinese, recorded its position and noted its brightness and color variations. In ancient Arabic astronomy, Betelgeuse's name is derived from the Arabic phrase, Yad al-Jaza, meaning the hand of the giant, reflecting its prominence in the night sky. The visibility and variability of Betelgeuse have inspired numerous legends and cultural references throughout history. In Greek mythology, the constellation Orion, in which Betelgeuse is located, is depicted as a hunter marked by this bright star on his shoulder. The star's changing brightness was often interpreted as a sign of strength or mood, influencing stories and beliefs across various cultures. Despite its cultural significance, Betelgeuse has been a focal point for scientific research. Observations using telescopes and spectroscopic instruments have provided detailed information about the star's physical properties, including its size, mass, temperature, and chemical composition. These observations have contributed to our understanding of stellar evolution and the life cycles of massive stars. Recent observations of Betelgeuse have reignited interest and speculation among astronomers. In late 2019 and early 2020, the star exhibited notable dimming episodes, leading to a significant decline in brightness. These dimming events caught the attention of the astronomical community, prompting theories about their underlying causes. One of the most discussed hypotheses is the possibility of Betelgeuse undergoing a supernova event in the relatively near future. Supernovae are explosive events that occur when massive stars exhaust their nuclear fuel and undergo gravitational collapse. If Betelgeuse were to go supernova, it would release an enormous amount of energy, becoming one of the brightest objects in the night sky, visible even during the day. The potential supernova of Betelgeuse has captured public imagination and scientific interest due to its proximity and visibility. Astronomers continue to monitor the star closely using telescopes and space-based observatories to gather data on its behavior and evolution. Betelgeuse's status as a red supergiant provides valuable insights into the later stages of stellar evolution, which involve the fusion of heavier elements in the star's core, leading to the production of essential elements like carbon, oxygen, and iron. Studying Betelgeuse and similar stars helps astronomers understand how stars evolve and enrich the universe with the chemical components necessary for planet formation and the emergence of life. Research on Betelgeuse also contributes to our understanding of cosmic phenomena and the role of massive stars in shaping galaxies. Massive stars like Betelgeuse play a crucial role in the chemical evolution of the interstellar medium, seeding future generations of stars and planetary systems with heavy elements. The variability and complex behavior of Betelgeuse challenge astrophysical models and theories. Understanding the mechanisms behind its pulsations and brightness changes requires advanced simulations and observational techniques. By testing and refining these models, astronomers can improve our understanding of stellar cycles and their broader implications for cosmic and astronomical evolution. Future observations of Betelgeuse will continue to play a vital role in advancing our understanding of stellar evolution and supernova phenomena. Long-term monitoring efforts using ground-based observatories and space telescopes will provide ongoing data on the star's variability, magnetic activity, and potential for a supernova event. Advances in observational technology, such as next-generation telescopes and adaptive optic systems, will enhance our ability to study Betelgeuse and other distant stars in remarkable detail. These advances will enable astronomers to delve deeper into the mysteries of stellar interiors and atmospheric dynamics. Combining observations across various wavelengths of light, from radio waves to gamma rays, will provide a comprehensive view of Betelgeuse's physical processes and interactions with its environment. Multi-wavelength studies are essential for unraveling the intricate relationships between magnetic fields, stellar winds, and the surrounding interstellar medium. Betelgeuse remains a cornerstone of astronomical exploration and discovery, offering significant insights into the life cycles of massive stars, cosmic evolution, and the origins of chemical elements in the universe. Its variability, historical significance, and potential for a supernova event make it a compelling subject for ongoing and future investigations. By continuing to explore and observe Betelgeuse, astronomers will deepen our understanding of stellar evolution and the dynamic processes that shape the universe.